Okay, so now that we know how to make functions, we can actually start to use them to make things that are interesting. So here we go. We're going to go through this slideshow together. Functions are a key part of animation in computer programs. So a function that draws a static picture of a cat, for example, can place the cat at different locations based on the input. When that input appears or changes slightly based on time or user interaction, the cat will appear to move. So this is how things change, right? And it's how they, used to make animations in the old days, when they were first making shows like Cinderella, Pinocchio, is they just made each frame slightly different from the last with the images that were not moving in the exact same place, but the images that were moving slightly changed. And if they did enough of those and moved them fast enough, then all of a sudden you see things change. Well, in a computer, you're doing the same thing. You're given the location of a rocket ship in this case, you can see, and then as, whatever this input here, it says 0, 1, 2, you can see that the location for that rocket ship is changing, and then what you happen when you go through and you do that fast enough, the rocket ship's height will change. So, let's see why I'm not getting I got Chrome hung up for a second. I'm going to give it just a second here. Got a little bit of a little tickle in my throat, so I am doing a lozenge as I'm trying to talk to you. Okay, here we go. So you can see what happens. They put the image, every time they adjust the height, the rocket gets redrawn, but now the location of the rocket has changed. All right, so now they want us to go to our workbook and work through page 12 and see if we can get this problem figured out, okay? So here we go, page 12. Sorry, get down there to page 12. Okay, problem is called rocket height, right? Rocket blasts off. It travels at 7 meters per second. They want you to write a function called rocket height. Takes in the number of seconds that have passed since the rocket took off, which produces the height of the rocket at that time. So our job is to start by writing out a contract and a purpose statement. Okay, so we start by writing the name of the contract here. What's the name going to be? Where do we get the name from? So to write this contract and purpose statement out, where we get the information here, we should be able to get right here from our word problem. And we should not move down to examples until we have everything we're going to need for those examples inside of here. So what's the function name? Well, it's given to us in the word problem. It should be called rocket-height. Rocket-height. So that's our name. What is its domain? What's it taking in? Number of seconds. So what should we write here, though? We write the data type. So this should say number. Right? It's taking in number. One number. That's it. And what is its range? What's it producing? And what it produces is the height of the rocket, which is going to be another number. So it's all it is a rocket height, takes in a number, returns another number. And how does it find the height? Well, the height is, changing on the rocket. It's changing on the rocket by a factor of 7 meters per second. So each second that goes by, we have to add 7, right? Plus 7, plus 7, plus 7, how many times, right? And that's when we get to multiplication, because we're going to multiply the number of seconds by 7. So in my contract, in my purpose statement, I would write this in. It takes in the number of seconds that have passed and finds the height by multiplying those seconds by 7. That's what it's going to actually do. Right? And let's see if I've got this. Oop, wrong page here. Go back up there. Sorry. Going down here to the right page, rocket height. Here we go. It produces the height of a rocket after a given number of seconds. Oh, I don't like it in here. It should tell us how it's going to produce it. What's it going to do? It's going to produce the height of the rocket by multiplying the given number of seconds by 7. It's going to multiply the given number of seconds by 7. Okay, so I'm going to have you, going to have you go ahead and see if you can get that figured out. See if you can, complete that word problem there on page 12 in your book. Right? Work out your examples and how it's going to work, what's it going to look like, and put in the definition. Okay? And once you have that done, back to where I need to go. Make sure you've got your contract, your name, your domain, your range. Then, you can check here. Okay, and I will let you see. Here it is. This is an example of a purpose statement. I like the good purpose statement here. Multiply the number of seconds by 7 to find the height. That's very good there, right? Okay. And now we can write our examples. So I hope you've already done yours. If you haven't, pause and do it. See if you can figure that out for yourself. But there's some examples. And now, once you've got your own examples in there, circle the parts. And it says circle only the parts of the examples that are changeable. So the parts that's changing, as you look at these examples, right? And he's broken it out to 2 lines. Here's the name, rocket height, took in 11, multiply 11, 7. So rocket height didn't change. The parentheses don't change. The 7 part here didn't change. The multiply didn't change. The part that changed was the input 11 and this factor of 11 in the multiplying, the input of 72 and the factor of 72. Those are the parts that changed. So we're going to have to give a variable for that, and a good variable would be seconds, right? Okay. And then by comparing the 2 different examples, easy to see what changed. According to the purpose statements, the number of seconds. So we would label that seconds. Should have it circled. Now, this is really important here, this part. So real quick, labeling what is changeable gives programmers a sense for the names of a function's variables. Variables are like placeholders for values, can be different at different times. A function that computed how much you pay for text messages each month, for example, might have a variable for the number of messages that you send in that month. The number of messages you send might change from month to month, but each one could still cost 20 cents as an example. But this is the part that's important. How many variables does rocket height have? So the answer should be 1, because you're only taking in the number of seconds and then using it as the number of seconds. It says what is the name of each variable. Well, there's a variable on the left and a variable on the right. It's the same variable, so you would use seconds both times, okay? Define the function using all the information, so you should be able to use your definition, and it should look like this, right? Rocket height takes in seconds, multiplies seconds by 7. All right. So stopping and thinking about the design recipe again. It allows a programmer to focus on one step of the problem at a time, use previous steps to help complete the next one. What does the contract tell the programmer about a function? The data types and what's it going to produce. Okay. What is the purpose statement? And also tells me the name of the function. Right. Tells me what type of data it's going to take in its domain and what type of data it's going to produce. Right. What does the purpose statement tell them? It tells them what the program is supposed to do related to the actual word problem. So by the time I'm down there doing examples, I should just be able to look at my purpose statement and get all the information out of my purpose statement I need to be able to write examples. I shouldn't have to go back up to the word problem. So in other words, this is important, I think, because what you want to do is, as you write out the problem that you're trying to solve with your program, then what you have to, a lot of the work gets done right here is you try to simplify that down into your purpose statement. You think through all the different, elements of that problem, and you say, okay, so this function, what exactly is it going to do? And you need to get it out of sometimes the wordiness of the actual word problem and simplify it down. What am I going to have this function itself actually do right now? And then I don't have to go back and understand all of the word problem to work with this function. All I have to do is read my purpose statement and know exactly what the intent is for this function, because it should be written into the purpose statement. Okay? Now, if I've got the contract and the purpose statement, writing examples should be a lot easier, okay? Because I know what I'm going to be taking in, and I've got the name in the contract. I know what I'm going to be taking in the contract as well, and the purpose statement tells me what it is I'm expecting to do with it, and so I should be able to write an example that does that thing with it. So why is it helpful to circle and label the parts that change? Well, that helps me identify variables that are going to be, used in the function. And how do all these steps help a programmer define a function? Makes it easy, because that last step, where you just write the definition, it seems like you could just skip a lot of this stuff and write out a definition. And trust me, a lot of programmers have done that. But your code can get sloppy, it can have errors, and people can certainly have a hard time trying to understand what the heck you're trying to do. Okay? Here it is in the examples. This is really a good idea too. In the examples, we show what we're trying to do and not the product. So we wanted, in the example, rocket height 7, or rocket height 11 rather, to write out the actual factors 11 and 7. If I put 77, then it's not clear to me that how I'm using my input, right? Or how I'm going to get that done. So the reason we're doing the example is not so we can write down just what the output should be, but so we can actually look at what our function needs to be defined as and all the parts of that function, how it's going to be defined, and identify which parts are the parts that change, that are going to be variables, and which are the parts that are not changing, that are going to be part of the definition. That's why we want to do it that way. Okay? Now, you have an actual link, okay, to this little rocket code thing, and it's pretty cool. I really like this. So if you go over here into Google Classroom and go to the technical math class, okay, technical math, you're going to see this link in here, and you can click on it, and it's rocket height. And when you hit rocket height right here, we hit run, okay, it says down here, it says the space bar adds 1 second and B goes back. So what happens when I press, if I'm pressing it, and I can see my time is changing. Watch. Every time I press it, I'm pressing now, the time is going up, but is it flying? No. B would make time go backwards. Time is going back down, but the spaceship isn't moving. And that's because if we take a look in here, the rocket height is not filled in correctly, right? In rocket height, I have one example only, and all it's returning is 0. I don't want it to return 0, right? So I need to get in there. When rocket height is 0, what should it actually return? It should return the product of 0 and 7. Okay, oops. And I'm going to copy this because I hit Control-C to copy, come down a line, and Control-V, and now I can just make a change. When it's at 10 seconds, it should be 10 times 7. So, in my definition, what's it going to do? Well, it's going to take that rocket height input of seconds, and it's going to multiply seconds by what factor? A factor of 7. Okay, and now I hit run. And now I can see that it's going up. Okay? So if you've done your page right, you should be able to get rocket height working. Okay? Now, this is pretty cool. Try some of these different ones here, okay? To see a graph of the flight path, okay, take this off, graph rocket height, and we'll hit run. So, hey, what happened there? What did I do wrong? Well, let me try this again. Oh, let's see, sorry, to see everything. Let's take that off. I don't think I can do all these at the same time. Let's hit run. Yeah, having problems there. Let's just do There we go. This is kind of cool. On this paper here, or in this image here, you can see over here is a little graph that we saw before. It shows that it's going up. Every time I press the space bar, it's going up. Over here, we're actually seeing how high it is. So now we're up at, what, 150 meters? Was it 7 meters per second, something like that? So anyway, we're getting up there, close to the heights of the Great Pyramid. But the way this is drawn, actually, you can see the scale is changing here. There's 100 meters. There's barely 200 meters. There's 300 meters. But now, the distance here to get all the way out to 1 kilometer, that's 1,000 meters. You can see it keeps getting smaller and smaller and smaller. So if I wanted to get out there to 100 kilometers, this is 1 kilometer, but 99 more kilometers just to get to the official edge of space. And I'm just holding down the space bar, and you can see it's taking me forever. We have a graph over here, and you can see the graph is showing that I am going up at 7 meters per second, and then it is not getting me there very fast, is it? I mean, I'm just holding it. It's been flying for 2 minutes, and I'm still not even up near where helicopters are at, right? Or forget about there. That's going to take forever, okay? So the point is, if I'm going to try to fly up at a constant speed of 7 meters per second, that might not be very good. And maybe what I want to do is not go by a constant speed of 7 meters per second. Maybe I want to do something exponential. So I want you to think about how you could do that. You may even have to go in and look at the documentation if you don't have the exponents stuff written down for math. But maybe if I could, I probably might want to get this going exponentially, okay? Which means I'm going to multiply some factor like 10 or 2 or whatever by to the what power, right? Maybe to the seconds power. So I'll let you think about that. And it's kind of cool because once you figure out how to make that work, you'll be able to see just how deep into space you're able to fly. It's pretty cool. That is a really cool little graphic that they have there. Okay? So the reason it didn't work, this is going over why it didn't work in there, which I've already covered with you. And you should be able to go in there and fix it and then make the rocket ship fly, which we just did. And then, let's see, some more practice. Here's one. Here's a couple for you to try, okay? Define a function, purple star, takes in the size of the star, produces an outlined purple star of the given size. Define a function, spot, takes in a color, produces a solid color, radius 50, filled in with that color. To find the average of two numbers, they should be added together and divided by 2. Define a function average, which takes in two numbers and produces their average. This is a good one, right? Because here we're going to need to do two things with those two numbers. We're going to have to sum them and then divide by 2. So this is a good one for us to make sure we get back to our circles of evaluation, right? Eventually, we're going to divide by 2. That's the last thing we're going to do. So that's the biggest circle. And then, how are we going to, what is it that we're dividing by 2? You have divide, you have some number that's going to be divided by 2, but the number is its own circle, right? And that circle is the sum of, the two numbers, that you provide. So it could be like X and Y, whatever two numbers you provide in your domain are going to be inside of this circle, and then that's going to be divided by 2. So you work on that and let me know. Send me a text or get a hold of me and just let me know if you have any problems and you're not able to figure that out, okay? Company logo is drawn in big red letters, rotated some number of degrees. Define a function. Logo takes in a company name and a rotation. So now we've got a name would be a string probably, right? A rotation is a number, degrees that you would provide, right? Some number of degrees produces a logo, okay? Include a good name for each function. Remember, domain and range can only include types like numbers, images, strings, etc. So I want you to work through. Those are some problems to work through. Contract is the foundation for a function. To give a programmer just enough information. And if you've done the contracts for each of those 4 problems, then you should do examples and then obviously define them. And that's what we're going to have you do. Okay? Get them all done. Now work on page 14 in your book. So 14, we'll skip past. You can do red square if you want in here. But lawn area, see if you can get lawn area figured out. Okay, name, contract, domain and range, purpose statement, okay, and circle and label what's changing. Do your examples, right, and then you can do your definition and then test it out. Make sure that it's working. So that's something for you to do. Here you have red square. It's the other function. I think it was on page 13. Go ahead and work on 13. Okay, do the same thing. Use the design recipe on page 13. Name, the contract, the domain, the range, the purpose statement. Write 2 examples and then write the definition to make sure it's working for you. Okay, make sure you're using the design recipe. Okay, it says once you learn how to use the design recipe, you can also do that using algebra as well. So here we have page 39 in your workbook. It says read the word problem carefully and write down the contract for the function. A rocket is flying from Earth to Mars at 80 miles per second. Write a function that describes the distance d the rocket has traveled as a function of time. So d depends on t, right? And is equal to 80 miles per second, so 80 times t. Okay, if you go through 39, let's see down here, get down here to page 39, you have to skip forward a bit and work on that problem. That would be really, really good. So 39 is right here, right? So there's the word problem. Have your contract written out, figure it out. And now what I really love about this is we've been practicing using the design recipe. You can actually work on this and think, how would I write an algebra function to do what this word problem says I should do? So at 1 second in, what should it do? 80 times 1, right? 2 seconds in, 80 times 2. 3, whatever, 15, whatever, 80 times 15, whatever. So down here we need a name for the parts that change. So D depends on something here, probably my guess would be T, and everything else equals would come down, and you would write down, you'd write down in here the stuff. Now, I'm just going to let you finish that out, but write it in algebra, okay? That's what we want you to do. Okay. Oh, and here's some answers. If you want to pause this, you can look at that. Kind of go through that, okay? Give you some examples. And you can write the contract, and then you can use algebraic syntax to go ahead and define and to get that defined. Define it using algebra, which means you're not writing the word define, you're using the equal sign and all that kind of part, okay? All right, so let's see. You can actually find averages pretty easy now that you've written that function, right? The hard part is setting up the function in the first place. The design recipe makes setting it up a lot easier, and so once you define functions using design recipe, you can start to make problems that are complex, into simpler problems and then combine them to solve more complex ones. So, suppose you wanted to know how far the rocket traveled in 6 seconds. Which of the 2 functions here would you use? What if you wanted to know how long it takes for the rocket to go 1,000 miles? So you would need to, maybe write a different function for that. So there you go. Page 41 in your workbook. You can work on this one here. Is this 41? Yeah, right here. Rocket leaves Earth, headed for Mars, 80 miles per second, the exact same time. Asteroid leaves Mars towards Earth, 70 miles per second. Distance from Earth to Mars, 50 million miles. How long will it take for them to meet? So work that through using the design recipe, but in algebra. And then you can solve this problem. This is a common kind of like pre-algebra or algebra problem that you might see, a word problem. And the way you're going to tackle it is you're going to tackle it just like you use the design recipe. And that's why I love Bootstrap, because, it's really, really closely tied to what we're trying to teach you to do in algebra. Solving for an unknown quantity there, okay? All right, so you can go through. There's some advice here. You can ask yourself, what are the facts it's giving me? What's the problem asking you for? Given blank, write a function that produces blank. You always think that way as you go through the word problem. And, what would you want to name that function? And I want you to go ahead and work through that, right? Okay. Here we go. If we had a function computed collision time, it'd be easy to answer this question just by plugging in the distance between Earth and Mars. And start worrying about setting up an equation, you use the design recipe to build the function itself. So I'll write down the contract for the function, and write 2 examples using different distances. You can figure out what's going to happen, for the collision there. Okay? And I'll let you work through that. Okay? And if you want to, you can pause and read through these screens as I'm kind of flipping through them already. My point is that the design recipe is awesome for both solving problems in Bootstrap or code, but also for even with your word problems that you're dealing with in math anytime. Okay, so good stuff. That is the end of the unit.